To review, if a function is even, then f of x must equal f of negative x, and the graph will be symmetrical across the y-axis. If a function is odd, then negative f of x will equal f of negative x, and the graph will have rotational symmetry about the origin, which means if we rotate the graph about the origin 180 degrees, the graph will remain unchanged. When determining whether a graph is odd or even or neither, I always like to look at the graph first. So here's the graph of f of x equals x to the fourth minus x squared minus 3. Right away, we should be able to recognize that if we were to fold this graph across the y-axis, or this line here, the two halves would match up perfectly, and therefore this has symmetry across the y-axis, and therefore this function is even. However, we're often asked to show that it's even algebraically, which means you want to show that f of x is equal to negative x. So let's go ahead and do that. Let's determine f of negative x and see if it's going to be the same function as f of x. So f of negative x would be equal to negative x raised to the fourth minus negative x to the second minus 3. So f of negative x is equal to, well, negative x to the fourth is going to be positive because we have an even number of negatives. So that'll be x to the fourth minus negative x squared is going to be positive x squared minus 3. Well, notice that f of negative x and f of x are equal to each other. F of x is equal to x to the fourth minus x squared minus 3. And therefore, once again, we've shown that the given function is even. We've shown it graphically, we've also shown it algebraically. And there is one more thing to mention. If we take a look at all the variables on the exponents, and if we had to have a variable on 3, we could write this as 3x to the 0, since x to the 0 is equal to 1. Notice all the exponents on all the variables are even, 0, 2, and 4. And when this is the case, the polynomial function will always be even, which we've already shown.